Hey, this is Edward. We're going to take a minute to measure a microphone using a reference microphone using Room EQ Wizard, which is an interesting FFT analysis tool, and it's a lot easier to use and set up than scientific instruments. So we're going to do that. Here it is right here. Now, to get it going, we have to set the preferences on this so we don't have to do a lot of work later. If you just press measure and you start measuring something, that actually works, but you're going to be resetting a lot of things in here later and with the measurement output. It's going to be annoying. So you can set the preferences up here at the top. Preferences, right? Control-Shift-E, or there's a button now to just hit that and you can bring up the menu. So the center menu on the screen it looks like this and has a few controls on it and has a few tabs across the top. And we need to set a few of these. And some of them don't make any difference to us right now. And some of them do. So the first one is the sound card one. Then we're going to go through the cal file one, of course, for the calibration files. And I guess set something with analysis in a second. Let's get started. The first thing you need is to select the driver that you're using to control the, to access the audio device, the interface. And you probably want to use the ASIO Steinberg ASIO driver if possible. So this side, this section right here, is the outputs, the speaker outputs, right? And so you would select your device, and then you'd select the output, like for instance, the speaker. If you have a left and a right speaker, this is left and right, you would say, well, oh, we're going to use the right one today. Okay. Now your calibration signal or your measurement signal will come out of that speaker. Cool. Now there's also a timing reference. It's a weird little signal with a chirp signal that the software uses to help it line up. And we're going to put that on the same output. Okay. Now on the input side here, you select the microphone that you're going to use. So for instance, this is the one I'm speaking on now, and this is another one we're going to use to measure, and then we're ready to go. So make sure to select the right one. That's nice. Let's move on to calibration files. All right, now we've moved on to the second tab, which we actually need. These are calibration files, and they are sort of offsets. If you had a measurement microphone that had no highs, you could get a special file from the microphone manufacturer that would give some set of values that show, you know, it needs more highs or whatever. Then you would just add the file. If you were using, say, an EMM6, there will be a file you've downloaded from the manufacturer with your own serial number that has your EMM6 calibration file, and it will have a serial number that is the number of your device. Then you just open it, and there you go. Now, anytime you use this, well, anytime you do a measurement now, it's going to add the calibration file to the data that comes in from the microphone. Okay. All right, let's move on to analysis. Most of this is not really necessary to deal with right now, except for this one thing we can see right here. Set window widths automatically. The window is well, this is hard to describe it. There's a windowed measurement. So as the sweep is sending a signal out, some kind of noise, the microphone is listening for that sound and not really anything else. But it's also including stuff from previous time. It's hard to describe, really, isn't it? So if a sound takes a long time to come back, like it goes way over there and it bounces off a wall and it comes back, you can select if you want the window to include that or to exclude it, right? Okay, so if you set it automatically, it'll usually set the width to 500 milliseconds. Now, sound goes about 1130 feet per second. You don't have to know this, but that's close to 1,000 feet in 1 second. A millisecond is 1,000th of a second. So a millisecond is about a foot long. That's kind of it. So if you set it to 500 feet, you see what I'm getting at? That means that a sound can go 250 feet away and come back and still make it in through the window. And so every reflection and echo and bounce in your room will be added to the chart. And you might just want to measure the microphone and not the room, or you might want to measure the room and not the microphone. So you'd want to change this window. So let's turn this to manual and shorten these measurement windows down to a distance that's shorter than the distance to your walls. So if your walls are, say, 5 feet away, then the closest wall that's a note, you don't want that sound bouncing off coming back, then you would change this to like less than 10 milliseconds. So if we just said 10 milliseconds right here, that means 10-foot distance of bouncing will be the maximum that it allows in, right? And you're just setting a default. It records the whole 500 or 1,000 milliseconds anyway. It's just that it will calculate the display that we want to see through that. So I'll explain more of that later. This is all we need in the preferences. So we're done here and we can get ready to begin. All right, we got the whole thing set up and we can go on to make our first measurement. Now what we're going to measure first, we're going to measure the response of the speaker that we're going to use to measure the response of another microphone. So we'll see. We'll hit measure and we open this crazy main control here. And we got a bunch of stuff here. We have a name, super test. Okay, good. If we move down, we see the range. This is the range, the frequency range that's going to be used. One thing really interesting is that since we set the time domain window to 10 milliseconds, that's not enough to do really low frequency. So some of the low frequency is going to be missing from this recording, and we'll look at that later too. This stuff over here has been set kind of the way we did in the preferences, if you remember, right? So we're ready to go. So we look at this metering, and we make sure we've got what we're doing here. So we want the noise to be below 40 dB. If we look at this line, we're way down there, aren't we? This is looking good. So 50 is pretty good. 40 is probably the worst you can go usable. And now that we've set the gain to where the let's see, where the microphone is down here, we're going to have to set the gain of the speaker to set the signal, and we want it to be up here between -20 and minus 10 dB. So you can hit check levels, and it'll generate a noise, and we're going to take a look and see what it does. Okay, that's a little low, but that'll be acceptable. So we could turn the speaker up a bit and make sure. Close enough. So now we're ready to take our first measurement. Let's hit it and see what happens. Okay, we got some interesting data here. We have this chart. You can scroll in and out in different areas to see. If you get lost, there is a control up here at the top right called limits, right? And this can set the limits to our chart. So right now we've got, say, 100, and then the bottom of this chart 70. We could actually do this if we really wanted to, right? 70, 100 to 20,000. Okay, so this is all the information we have available from this device, and that's awesome, right? So we're good. So we've got to make this information into a reference that we can use to measure microphones. So here it is on the top left. But we need to make just this recording into a calibration file of its own. So in other words, if something responds like this, then it should show you a flat line. And if it responds differently, then you'll be able to tell the difference, right? That's the point. What's the difference between this and the microphone we're testing, right? Well, cool. Well, we can press File, Export as text, okay? File, this file, anyone you're selecting, right? So it's this one. Export as text, and it'll make a text file just the same as the reference file. We're building a reference, this sort, right? So press OK, and you give it a name like test microphone thing with speaker that's 3 inches away from thing, whatever, and then you just press save. If we went to this file, since this is it, and we change the calibration file to itself, right? Special testing 1000, then the output will become flat because it's subtracted from itself. And there it is. This black line is the reference file, right? We can turn that off. And now we can see the response of the microphone is, including the speaker compared to itself, is 0, right? So cool, right? There. So the response is perfect. Right, okay. So if we did another test and we used that calibration file, then we would be able to see this line. Now, if we were doing these over and over again, we would want to use the calibration file all the time, right? So what we could do, which is kind of wrong, is we could go back to preferences. You remember this? We could go to calibration files, and we could actually put the stupid calibration file we made in there. Now the microphone is running that. So if we measure again, then you can see the response is almost perfectly flat. Now there's a little bit of a, stuff, but this is functionally perfect, right? So that's kind of the same thing as this. Cool, right? Interesting, huh? Now, if we put another microphone in, then we can just hit it again. So let's say we had another one like this, and then we were to test that. We could just plug the mic in and then press go at this point. All right. What we have here is something with a very different response, and you can see it compared to the flat response of our measurement microphone against itself. This microphone has a totally different response. Up here at the top, there's a button called Overlays, and it'll open a separate window. A lot of these extra little tools are like this. And this window will show you everybody. You see that here they are, right against each other. So you can see, well, yeah, they are the same here. They're the same throughout here. And there is this roll off. It's almost like a high pass filter in 100. We're at -10. It's significant, isn't it? So we can see exactly how the roll off behaves. We can kind of see what's going on here, right? That's pretty interesting, isn't it? So what if these are all at different heights? I screwed this up on purpose so we can see. And we can't make a good comparison because they're all over the place or something like that. But typically, people normalize these files to 0 dB at 1,000. So you would think, well, am I going to move these around manually or something like that? There's a tool here. If you get rid of the overlays, if you look at each of these files, we can see 0 is pretty close to this one, right? But this one is way off, obviously. 0's down here. That's not right, right? This one's way down here. Then there's a tool. It's up here. Controls, Align SPL. Controls, right? Align SPL. It will move the middle 1,000 cycles here to position 0, right? It'll just move the whole chart. And it can span or average a bunch of space. So here I move it. Now it moved everything to 0, right? Perfect. We go to this one. We can do the same thing. Align SPL, right? 1 to 0. Okay. Now, if we look at this on the overlays, we can see something interesting about this chart. The yellow line, notice that it's generally above. It's not lined up properly. You see, it's a little high. That's because the moment where 1,000 is, it aligned out with 0 just fine, but it didn't average over a little bit of an area. So we can go back out here, hit Align SPL, and then increase this alignment span to an octave, right? Now it moves it back down where they match because it's using the whole area. It's about an octave wide. So now we've got an idea of what's actually going on here. So now we've got a pretty good story here. We can see what's going on. This mic is thinner, has no bass, and has all kinds of highs. All right, cool.